Electronic nose is an instrument that's been developed here at Warwick University, and it consists of an array of sensors, and attached to those sensors is a pattern recognition system, and we use this to mimic the human sense of smell.
Here we have kind of what we would see as more of a traditional electronic nose. We have a series of different types of chemical sensors. Now these chemical sensors respond to different types of molecules or odours within the atmosphere. And what a normal electronic nose does is that it looks at all these multiple components, and each sensor responds to a group of these. So they're not specifically tuned to, for example, one chemical, but a group of chemicals. What we've done here is we've created kind of a traditional electronic nose to begin with. Onto this we've put a series of chemical coatings. So here we have 80 chemical coatings with varying different tunabilities. Now these sensor coatings are actually a rubber which have been mixed with carbon black. Now what this happens is that a rubber is insulating, and the carbon black allows the polymer to conduct. So it gives you a path for conduction. And when you put an odour across here, the polymer actually swells, so it just enlarges. And the conduction path through the material changes because these carbon balls move. Now what we've done that's special is we've added this micro package. We've created a package which has this mucus layer within it. And so we fabricated this out of plastic using this machine. And then coated it after we've built it with a layer of kind of polymer. It's clear, not green, but it's a similar thing. What this mucus layer does is, if you can imagine in the morning you go and smell some coffee, you can tell that it's coffee. And what your human nose does and this nose does is that as that coffee smell goes into your nose, the mucus layer here and there separates out the different chemical components. This is our microstereolithography equipment, and we use these to fabricate micropackages such as this. If we wanted to create an object, first what we do is we create or draw a 3D CAD file of this object. Once we've created that, we send it to the machine, and the machine slices that 3D object into a series of 2D layers. So if you were going to make something like the Eiffel Tower, you would draw the Eiffel Tower and then you would slice it into a series of 2D layers and build each of these layers one after another. The machine works on a process called photopolymerization. So inside here is simply put an overhead projector, a posh overhead projector. And it takes one of those 2D images and shines it upwards from the base of the machine. Now a layer of this red resin is trapped between this, which is the build platform, and this, the base platform. And as the light comes up, it cures a layer of this resin. And this is one of the reasons why this room is yellow. The frequency of light which performs this process is basically a deep blue. And so what we've done here is we've cut all the blue out of the room, so when we're taking parts in and out of the machine, it doesn't cure the resin. So when you're trying to do really fine detail, you need to keep the blue light out as much as possible. So this kind of 2D build process just is repeated again and again and again until the part basically comes out of the goo. When you give an odour to one of these systems, all you get is a series of sensor responses, which is we call a spatial response, and we get a temporal response, which is a delay. So the sensor's responding to these kind of odour pulses as they come along. So what we then have to do is take this data. I mean, for example, here we have 80 sensors and a test might last 5 minutes. So you'll have a huge amount of data, and we have to convert that into something that we can teach a computer. So normally we have a program called like a neural network, and we teach it to understand or recognize these different responses to a series of different odours. So you might train it on 5 or 6 different chemicals, milk, banana, orange juice, etc. And you would look at the response and the temporal delay. And then when the sensor array was given the same odour again, it's learnt it. So the computer would say, oh yes, this is orange. One of the problems with, or has been with electronics nose, is its sensitivity or selectivity. So it struggled to detect or separate out 2 different chemicals within it. So if you mixed orange and banana, say, it would struggle to separate the 2. And this is really where this micro package comes in. So by separating out these chemical odours as they travel along the nose, you've got more chance of being able to separate out 2 different or very similar components, and also see very low concentration of one smell in a background odour of a very large smell. At the moment, the main uses would be things like food industry, beverages, those kind of things, freshness of fish, that kind of thing, but also things like environmental monitoring. So you can use it for, we've used it for looking at blue-green algae, those kind of issues.
And what we've been working on in the last 5 years is to develop very low-cost technology for handheld electronic noses that go into telephones, mobile phones, rather than great big desktop instruments. Working with Siemens, and Siemens is quite interested in this, we could diagnose illness perhaps from breath analysis. So the idea is that you could breathe into your phone that had an electronic nose, and it would classify what sort of bacterial infection you got, and then you could know what sort of prescription you need.